So in this lecture, we talk about forecasting, especially demand forecasting problem. Forecasting is a foundation of any inventory management problems or method. So if we do not have data, basically, subjective judgment is a kind of forecasting, but normally unreliable. So we always emphasize you should have some kind of forecasting system so that you can have more analysis for your business. So the learning objectives, we have only one lecture about the demand forecasting. So I suppose you have started forecasting, simple forecasting method or the models in the bachelor level. So we just summarize the forecasting process and the framework, and then we talk about how to evaluate the quality of the demand forecast, and then should be able to do to apply the traditional forecasting method, including moving average, exponential smoothing, and a simple time series analysis. Of course, if you're interested in this topic, strongly suggest you to take the elective course in the next semester or in the BI program. They have a course just called business forecasting. I think analytical analysis will definitely be the future of the business. So it's worth to give a try. So the 5-step approach to implement forecasting. So first, you need to collect the data, include the old data forecasts and actual demand outcomes. So that's actually always something easily neglected. So here we especially talking about the old data forecasts. So it's natural we collect the real historical sales and the historical behaviors of the customers and so on. But we normally do not consider what is the old data forecast, but that's actually normally also interesting and important. Establish the forecasting method. So you decide on the balance between the subjective and the objective data while looking for the trends and seasonality. So the method actually, regardless of the complexity of the modern method or the theories, but normally all the method will focus on talking about the trends and the seasonality. All the other factors like advertisement or promotions actually not part of the market uncertainty, these controllable factors. So forecast the future demands using a forecast method. So that's actually implementation of your forecasting model or the method. And make decisions based on the step 3. So step 3 only give you suggestions. So you need to actually adjust the forecast to be useful in practice. So that's why we say you need to make decisions. And measure the forecast error, look for bias and improve the process. So any method you need to actually evaluate the quality, otherwise it cannot actually guarantee it will work or fit into the truth. So in our next lecture about news window models, so the textbook give you an example to show why it's important you need to have both old data forecasts and the demand outcomes. So forecasting is a process of creating statements about outcome of variables that presently are uncertain and will only be realized in the future. So here we're talking about the variables is mainly in the economics context. So in our area, retailer management or inventory management or supply chain management, we normally focus on the demand forecasting. So demand forecasting is a process of creating statements about the future realizations of demand. So that's actually will directly lead to your decisions about inventories and all other decisions. So the demand forecasting, including the time series analysis. So if you have a series of old historical demand data, then you can use them to forecast the future. And then there are time series based forecast. So this is an approach. So the approach to forecasting that uses nothing but old demand data. And then extrapolation. So that's actually estimation of the values beyond the range of the original observations by assuming that some patterns in the values present within the range will also preview outside the range. So apart from the information you can interpret from the old data, should also be able to work on the data, try to explore some outside possibilities or the patterns. So apart from time series analysis, there are also regression analysis. So a regression method is a statistical method. So regression analysis is a statistical process of estimating the relations of one variable with multiple influences that influence the variable. So in that case, we need dependent variables. So the variable that we try to explain in a regression analysis, for example, we call it y, and then probably yt, and then we also need to know the independent variables. The variables influence the dependent variables. So for example, it's xi and xit, or this type variables. Then probably you can find a relationship between these independent variables and the dependent variables. For example, for a linear relation, so you could have a at plus so alpha 0, so alpha 1, and then xit z1, and then plus alpha 2 x1 t x2 t, and so on. So if you have multiple independent variables, for example, it can be an advertisement, can be a price, and you can add more promotion and add more like weather. So that's possible. You can do this type of analysis, and in the end, this must be something called error or the random factors for this dependent variable. So this is not a strict formula. This just one assumption. If you do regression, basically you try to find the relations between the independent variables and the dependent variables. And then also automated forecasting, the forecasts that are created by computers, typically with no human intervention. So regression analysis is very often used in the economics context. Automated forecasting normally is integrated in your information system or ERP system or inventory management system or something IT supported system. So it could have actually help you to directly forecast the demand. So this actually very often come from the project company project ask is, oh, we need somebody to improve our forecasting. So they may have some forecasting method. Then your contribution, if you take such a project, then your contribution would be to improve the forecasting method or forecasting model. Furthermore, the forecasting can also be classified as expert panel forecasting. So forecasts generated using subjective opinion of the management. So if you are a store manager, you probably just estimate what you could sell in next week, and then make an order from your distribution center or something. So that's actually subjective opinions of the management. And then the buyer also actually forecasts, quite likely in many companies in the procurement part. So they do use forecast, but normally the buyer just forecast how many they would like to buy. So that's actually very subjective judgment. And also short-term forecasts used to support tactical decision making with typical time ranges from hours to weeks. So this actually what I experienced yesterday. I went to Tia Hansen to buy some product, and then they said currently this product is out of stock, and then the worker in the employee in the job floor in the shop floor can directly place an order in their computer and say you can come to pick up this item tomorrow. And he told me actually I ordered 3 more items. So that's basically a short-term and quick guess. So it's also a short forecast for hours or for weeks. And if you sell coffee, you probably just estimate how many cups you can sell in next hour. So it's normally it's a short-term forecast, and then you can prepare your materials. You can prepare for the workforce for the next hours services. And also there are midterm forecasts used to support capacity planning and financial accounting with time ranges from weeks to a year. So this actually normally talking about an entire selling season. So for example, if you sell the furniture, then you're probably interested in next entire year how many units you can sell, and then you can arrange how many raw materials you should procure and how many workers you should hire to work, and so on. So it's a typical capacity planning level forecasts. And also long-term forecasts used to support strategic decisions with a typical range of multiple years. So that's actually normally subjective. It's just looking forward in 3 years what the market will look like, and will you invest more on one specific product, or you plan to actually change your focus from the current market and so on. So strategic decisions. So after we talk about the forecasting framework, then we can talk about how to do a forecast. However, before you choose any specific forecasting method, you should know how to evaluate the quality of a forecast. So we first look into how to evaluate the quality of a forecast here. So the quality of the forecast can only be assessed after the real outcomes have been observed. So basically the idea is to use the realized outcome to compare with your forecast. Then you will know how good it was. So first there are 2 standards or 2 criteria to evaluate. First is called unbiased. So that means your estimate on average actually is the same with real outcomes. So basically, if you see you have an average for your estimated value equals to the average, the real value. So that means it is good. And this hat means this is a forecast or estimated value, and YT is a real outcome. So here we basically compare with the average. And the second method is called close to the real outcomes as measured by either the mean square error or the mean absolute error. So this is called MSE or MAE. So sometimes it's called MSD or MSE and MAD. So that's just the same meaning, with a different name. So MAE is mean absolute error, MAD is mean absolute deviation. And then we have the forecast error directly measured as the difference between a forecasted value and the realized value. So forecast error basically is a YT minus YT. And unbiased forecast, a forecast that is correct on average, thus an average forecast error equals to 0. That means if we do not talk about Y, then this actually means your forecast is unbiased. And then biased forecast is a forecast that is wrong at average. The average forecast error different from 0. So then the mean difference is not equals to 0. Then your estimate basically is biased. So if this is greater than 0 and then less than 0, basically is a bit overestimated. So less than, then that's underestimated. And equals to 0, then that's unbiased. So regarding the forecast error for the individual forecasts, we actually have the method. So later on we talk about MSE and MAE. So we continue to talk about the forecast error. So this should be forecast for YT minus actual YT, and then MSE is a square of the forecasted error. So we use square values because the value will always be positive or non-negative. Then the error will not be cancelled each other. And then MAE, a measure evaluating the quality of a forecast by looking at the average. So you can see we're interested in the absolute average value. So this absolute value also make sure the difference is all positive. So because the smaller and the greater both are not good, so we just integrate the effect on the both way. And then determine if a forecast is a good forecast using a matrix. So you actually can use multiple measures to evaluate the quality. Since MAE and MSE both have advantages and disadvantages, so it would be good you can use them both. But in the numerical examples in this lecture, I only consider the one specific time, but you're totally encouraged to use both of them. As we can see, the MSE actually would highlight or actually exaggerate the single mistake. So if you have multiple forecasts, but as long as one forecast has a very large error, then it will definitely weighted up in your entire error evaluation. So it will actually affect your forecast in the end. So as we have done in the numerical example, I have used the forecast error, the mean forecast error, to actually optimize the smooth parameters. So just remember, if you want to determine the smoothing parameters in your forecast, you quite likely need to have a forecast error to be optimized. So the purpose of forecasting actually is to explore the pure noise. So if we can find trends, seasonality, or other systematic factors in your sales or in your data, then these are all controllable factors as predictable. But if there are some variables influence the outcome your process, but we cannot predict it, then that's called noise, or we call it statistical noise. And then the naive forecasting method is just to consider the future forecasts equals to last period realization of your demand. So this is naive method. They basically ignored anything, any systematic factors in your data, in your sales. We just consider the sales as a whole. So you may already question the naive method may be often unreliable because from one period to next period may be related, but there are also many differences. So there are also the impact from the entire process may be collected from the historical long time experiences. So here we're talking about, we should also consider the previous realization of your sales. Then the first method to integrate more historical data into your forecast is a moving averages. So moving average forecasting method is a method that predicts the next value will be the average of the last m realized values. So of course, the closer the period, then maybe this reflects more reality. So you can decide to choose the average of the last 3 periods, 4 periods, or 5 periods. So we have examples. So actually, it's no longer called the data sales data example. It's actually called moving average and exponential smoothing examples. So this actually is in the Blackboard now. So now you can check the data example. I found this data online. So this is a large data set with the sales of multiple stores, multiple items in multiple years. So I just pick up some of the data to try out the forecasting method here we mentioned. So I do not go back to the Excel to show how to do that. So if you're interested, you can see also a screencast to talk about how to do a moving average in Excel. So another method to actually combine the historical data, sales data or demand data into the future forecast is called exponential smoothing method. So this method is this method predicts the next value will be a weighted average between the last realized value and the old forecasts. So now you can see t plus 1 is a future, and then we have the realized data for period t, and we have also the forecast for the previous period t. Then if you add them weighted sum, so alpha is called a smoothing parameter. Use alpha to get a weighted sum of the current realized demand and the historical realized demand. So in the textbook, they try to explain why this formula is a weighted sum of the current value and the previous value. So if you do an iterative extension for this formula, then you can see this yt estimated value equals to alpha yp t minus 1 plus 1 minus alpha t minus 1 estimated. So if you substituted this value to the ft yt estimated, then you can see your formula become alpha yt plus 1 minus alpha times alpha minus t minus 1 plus 1 minus alpha square yt minus 1. And then of course you can continue to expand the yt minus 1 equals to alpha t minus 2 plus 1 minus alpha yt minus 2 estimated. Then you can actually just expand this formula for yt plus 1 estimate. Basically is a weighted sum. So the value of the weight is related to alpha. If I use wt to represent it, then the t equals to 1 until the current period, so to t. So I equals to 1 to t, and then wi, and you actually have yi. So that's actually the in the end you got this weighted sum. Of course, this omega value you can see in the for the current period you have the weight alpha. So for the next period is one period before. So this weight is smaller and the weight even smaller, and then you can see the newer the data is, then the weight is larger. So that's how you how this method was designed. And then it doesn't matter for you to understand these formulas or not. As more important, you can do this type of forecasting in your Excel. So again, this is an example file with a new name, MA, and exponential smoothing examples in Blackboard. So you can find this file and to try the exponential smoothing. The good thing is not necessary you do all this smoothing. So Excel has a data analysis pack. Pack, I don't remember. And in the data analysis tool, you actually can find exponential smoothing. So that's more important. You understand what's the meaning of alpha. So you want to add a higher value alpha or you want a smaller alpha. And then you can directly generate the output from Excel. So it's an automatic process. So if we in the lecture time, then we probably just go to the Excel to see the examples. But here I just suggest you to go to Excel to check the model and the method, and there is also a video available for that. So the time series analysis trend. The trend is a continuing increase or decrease in a variable that is consistent over a longer period of time. So now we're talking about this trend actually can be identified through a relatively long period of the time. And then you can also do the momentum-based forecasting. So an approach to forecasting that assumes that the trend in the future will be similar to the trend in the past. So that's actually the assumption for the time series analysis with the trends. So we'll assume this identified trend in the current period will hold in the future. And the double exponential smoothing is a way of forecasting a demand process with a trend. So this method estimates both the demand and the trends using exponential smoothing method. The resulting forecasting is the sum of these two estimates. So this is just the wordy explanation. So here in this slide, you can see the implementation of the double exponential smoothing method. So here we're talking about first you forecast the trend. So you can actually identify the trend, and then this trend will be integrated when you forecast the demand to for your product. So here the trend actually is from exponential. So this process is one, or we call it first exponential smoothing. And then the original demand is also smoothed over time. So this actually, the smoothing process may just missing the trend, because you just smooth out the trend from period to period, take the average. So here we just do another, so we call it first and we call it second exponential smoothing. Then this is actually a double exponential smoothing process. So the calculation is mainly based on these formulas. In the textbook, they assume your start is 360, and then the start value for your trend is 5, and then the 368, the first forecast. I think there's unreasonability in this layout. So the first value should be in the week 1, so we can take the naive value for the previous forecast. So here this 368 should be the forecast for period 2. So that's what how I adjust this layout in Excel. Otherwise, this calculation will not lead to the optimal smoothing parameters. But this is the method you should implement. And then so the trend, you use the formula for the T trend forecast, and then you have initial value for T0. So according to the formula for the period 1, we actually need, so we estimate the demand for period 1, we should have alpha y0 plus 1 minus alpha y0. So if we have a forecast of y0, we also need a realized y0. We do not have that. So the suggestion is we just postpone this entire forecast for one period. We take the, in the Excel, what we did is to take the y1 equals to 360, y1 estimate, and then the y1 realized is 370. Then we start from estimate y2 equals to alpha times 300, y1 estimated plus, sorry, it's not estimated, so should be y1 plus 1 minus alpha times y1 estimated, and then you can continue this process. So this is actually the exponential smoothing method. As I mentioned, you can do that manually if you want to follow the entire process. Otherwise, you can just use Excel to automatically do this process for you. So another commonly seen feature or characteristics of your time series is the seasonality. So that's very often we can see you sell some products, for example, gardening products or the summer garden furniture. Sorry, excuse me, and they always have this patterns of sales. So now we can see how can we actually forecast the seasonality or estimate the seasonality when you do a forecasting. So the seasonality is a significant demand change that constitutes a repetitive fluctuation over time. So seasonality index is an estimation. You use a multiplicative adjustment factor to actually adjust the forecast to integrate the seasonality. So here we actually create two words. One is called deseasonalized, and then another one called reseasonized. So deseasonized means you remove first the seasonality from the real data, historical data. Reseasonality means you actually add the seasonality back to your forecast result outcome. There are actually many different methods to measure seasonality. So here in the textbook, they use a very simple method. So if you estimate the season X demand, average demand, then divided by the average total demand, then this will show you somehow the seasonality. And then deseasonalize the demand in the period D is to use the demand then in seasonality T to divide it by the seasonality index. So that means if your seasonality value is actually less than 1, then you actually have a higher or greater deseasonalized demand. And then if your seasonality index is greater than 1, you will have a smaller forecast deseasonalized demand. So we use X to show the number of the season. So forecast for next season, X is a smooth forecast for an average of day, and use the last value in your deseasonalized smooth exponential forecast times the seasonality factor. Let's see how can we do that in the example. So this is our example in the Excel. So textbook example how to forecast the demand with the seasonality. So as we said, first you need to calculate the seasonality index. So the idea to calculate the average demand for the entire time series, and then you calculate average demand for Monday, Tuesday, and then that's how you calculate the values. So average X, season X demand divided by average total demand, and then you just reuse this value for Monday to Sunday 3 times in 3 years. And then we can see there are the plots about your historical sales, so that somehow shows that's probably some pattern. For example, always in Monday you have a rather high demand, and then in Sunday it's probably Saturday a bit lower, and then you do a deseasonalize the data. So you use emergency visit and divided by your seasonality, and then you do exponential smoothing for the deseasonalized data, and you got a smooth forecast, and then you do a forecast. So this forecast just bring the seasonality back to times, so smooth forecast times seasonality, then you got so it's a column F times SI, you got the forecast. So the interesting part is here in the end. So when you do the forecast for the future, then you have a week 1, week 3, and now you are in the week 4, and then you only consider the smooth forecast for the previous period, and plus the use this value times your seasonality, and then times seasonality index, then you got your forecast. So in this example, the smooth parameter is 0.25. So this is just one try. So you can try other values. So we do not actually try many different parameters. So the suggestions, you could actually use Excel solver to directly optimize this value. So you can check Excel example about how to optimize your smooth parameters. So the idea is actually to minimize your mean. So idea is to minimize your mean absolute deviation. So here this value is FE, and then in the end this value is MAD. So we try to minimize the last average value over all this forecasting error. Of course, we use the absolute value for the forecast and the real values. So we use YT minus YT. So we do not show the optimization process in this video. So you're interested, and then check Excel. So here we actually also introduce you the method, a hot and a wind method. So this actually is the method to predict the demand based on the time series with both trend and seasonality. So the method is just integrate the two methods we introduced about time series previously into one method, one model. So in this slide you can see I use another example, which is a sales. So you have the units sold, historical data for multiple periods previously. You can see this quarter. So there's missing one column. So it's actually different years. So year 1, year 2, year 3, and year 4. So I have 218 until 2020. So that's actually clearly explained in the video or screencast and Excel file. So if you're interested, you can check that. So here I just try to explain if we plot this unit sold data in the chart. Now you can see the data has basically kind of a seasonality shows in the quarter 3. It normally has a peak selling, and in the quarter 1, probably winter, actually has a lower selling. And then you can also see if we predict the sales in general actually is increasing somehow. So now how should we actually predict the demand? So the idea is we should predict both seasonality and the trend, and then bring them back to your forecast. So the idea is to first calculate the first cycles. So we need initial seasonality. What I did here is to use a method in the textbook to have an average seasonality, and then we actually deseasonize the second year's demand by the seasonality from the first cycle, and then you can use a double exponential smoothing to estimate one level and one trend. So level is the estimate for deseasonalized sales, and then the trend is based on the exponential smoothing for current trend and the previous trend. So for the more technical details, you can check another video. So here we actually use 3 exponential smoothings. We also smooth the seasonality index. So here we actually use gamma to smooth the seasonality index, and a beta for trends. So gamma is for seasonality, and alpha is for level. So it's a three-folded exponential smoothing. So if you have such a time series on the data, you can always check if this model can be used. So far, we have introduced all the traditional forecasting method. As I said, business forecasting actually become a very hot topic, especially when the data science is rapidly developed. So there are a lot of new methods, especially big data driven. so we cannot actually go through them. But it will be interesting if you have a look at other articles or the textbooks about forecasting, if you need to use them. So expert panels and subjective forecasting is another type of forecasting often used in practice if you do not have a well-established forecasting system or method or model. So here we're talking about forecast combination. So you can combine multiple forecasts that have been generated by different methods, different forecasters, and then forecast with consensus building, so an iterative discussion among the experts about their forecasts and opinions that leads to a single forecast. The textbook actually uses 4 doctors' forecasts for the patients, but you can also use 4 salespersons' forecast for sales. And then prediction markets, so a betting game in which forecasters can place a financial bet on their forecasts. So that's actually really risky. This expert panels is actually well used, but we do suggest to combine with the structured forecasting method. And the subjective forecasting should always be censored or evaluated by multiple experts. As we said, the expert panels or the subjective forecasting actually have some obvious drawbacks. For example, overconfidence bias. So some people are very bold or risk adverse, so they prefer to take the risk. So they may have actually the overestimated forecast. So the fact that human decision makers are overly confident in their ability to shape a positive outcome. And then anchor bias, that also should be considered. The fact that human decision makers are selective in their acquisition of new information looking forward confirms their initiality or initial held beliefs. So that's actually often incurs if you want some evidence to support or in your favor, then they may actually convince you that's the right thing. And the forecast gaming, this is a purposeful manipulation of a forecast in order to obtain a certain decision outcome for a decision that is based on the forecast. So that's actually often used for some experts. They know the system very well. They can actually manipulate the forecast. So if you got time, you can try to do the exercise 13.6. The answer of the exercise is also in the textbook. You can give it a try. There is also extra data set for in Excel example file, and that's for hot and winter method, so both trend and seasonality included. So you can also try that one. And the next time we talk about the simplest inventory model, Newton-Winder model. So the focus will be the performance of the stock decisions.